by following the three factors, we can give the stability order of different carbonium ions like in this manner. It is triphenyl carbonium ion. Triphenyl means 3 benzene rings surrounding a carbon plus ion. So it shows more resonance, so it is more stabilized than diphenyl carbonium ion, and this is more stable than trimethyl carbonium ion, which is a tertiary carbonium ion. In the first case, the resonance effect will operate, and in the second case also resonance effect operates, but in the third case plus I effect and hyperconjugation effect will operate. Hyperconjugation by 9 alpha hydrogens. So, and in the fourth one, benzyl carbonium ion, phenyl substituted methyl group, that is the benzyl carbonium ion. In this, only one benzene ring is present, which shows the resonance effect, and there are no alpha hydrogens, so no hyperconjugation or plus I effect. It is the resonance effect shown by one phenyl ring is less than the inductive effect caused by 3 methyl groups and also 9 alpha hydrogens, which cause the hyperconjugation. So, trimethyl carbonium ion, that is the tertiary carbonium ion, is more stable than benzyl carbonium ion. These two effects will overweigh the resonance effect caused by one benzene ring. So this order is more important. And next comes allyl group, allyl carbonium ion. This allyl carbon shows the resonance effect by the delocalization of pi electrons, and this is a secondary carbonium ion. It is secondary, and these are primary carbonium ions. This is the order of the stability of different carbonium ions. Okay, students, here what we have to remember is it is triphenyl, this is diphenyl, and phenyl carbonium ion is coming after trimethyl carbonium ion. This point you have to remember. And then allyl, secondary carbonium ion, primary and primary. Now let us see these examples A, B and C. These are the previously given questions. The carbonium ion position is on the cyclohexene. It is cyclohexene which is in conjugation with a pi bond in these two structures, and here there are no pi bonds. So in structure A, this is stabilized by resonance and it is stabilized by the inductive effect also, and also 3 alpha hydrogens. So 3 effects are operating in the first structure: resonance, 3 alpha hydrogens, and this inductive effect caused by the adjacent CH2 group and also methyl group, plus I effect. All the 3 are operating in this structure, and in the second one the resonance structure is operating and 1 plus I effect and 2 alpha hydrogens. Here there are 5 alpha hydrogens, 2 here and 3 here, 5 alpha hydrogens, and in this resonance effect 2 alpha hydrogens and 1 plus I group, 1 group causing plus I effect in the second one, and in the third one there is no resonance possible, no resonance effect, and hyperconjugation is given by 2 plus 2, 4 hydrogens, 4 alpha hydrogens, and these are the plus I effect causing groups, plus I effect. So among these, which is more stable? A will be more stable because in this, these are the 3 factors which are causing the stability, which are increasing the stability of carbonium ion, which are stabilizing the carbonium ion, and in this the number of hydrogens, alpha hydrogens is less, so A is more stable than B, and in this no resonance, so it is least stable. So A greater than B greater than C is the stability order of these three species. Coming to the next pair, this is one set, another set. This is allyl carbon, tertiary carbonium ion and secondary carbonium ion. By seeing the order, we can say this has resonance. It has resonance, so it is more stable. This is the tertiary carbonium ion. It has resonance, but this is allyl carbon. The allyl carbon is less stable than trimethyl carbonium ion. So these are 9 alpha hydrogens and 3 plus I effect causing groups. So it is more stable. And in the third one, 2 methyl groups and 6 alpha hydrogens. So the stability order will be, this is more stable, B is more stable than A, which is more stable than C. The order is B greater than A greater than C. Okay students, so we have to consider the three factors and the stability order. This is an anomaly which you have to keep in mind while assigning the stability order. Okay students, the next example students, these are very interesting. These are dependent on the position of the substituents present on the benzene ring. We have to consider the position also while giving the priorities or while assigning the stability to the carbonium ion. In this is benzyl carbonium ion, and at ortho position methyl, isopropyl and tertiary butyl groups are substituted. Now this methyl group is in resonance with these double bonds. So this shows plus I effect, plus I effect. Plus I effect is shown by methyl group, and there are 2 methyl groups and 3 methyl groups. By considering the plus I effect, what will be the stability order of these three species? For example, A, B and C. What is the order of these three? This is 3 methyl groups which will cause the plus I effect. So this will be more stabilized, which is in conjugation with the double bonds. So we will think that based on the plus I effect, the stability order will be C greater than B greater than A. Okay students, if we consider the hyperconjugation is shown by the hydrogens present on the alpha carbon atoms. In this, alpha carbon means the carbon adjacent to the double bonded carbon. In this case, because these double bonded, the pi electrons are showing the resonance. So this carbon attached to the benzene is the alpha carbon. How many alpha hydrogens are present on each one? In this, 3 alpha hydrogens. In the first case, 3 alpha hydrogens, and in the second case, 1 alpha hydrogen, and in the third case, no alpha hydrogens. So if we consider the hyperconjugation, what is the stability order? Here 3 alpha hydrogen, so it is more stabilized than B, which has only 1 alpha hydrogen and it has no alpha hydrogen. So the stability order will be A greater than B greater than C. Now which is the correct answer? Which is the correct answer? If we consider the inductive effect, C greater than B greater than A. If we consider the hyperconjugation, A greater than B greater than C. Inductive effect is less effective over the hyperconjugation. On the order of stability, on the order of different effects, resonance effect is more effective over hyperconjugation, which is more effective than inductive effect. That is one point. And another one is here, this is the inductive effect is distance dependent. Inductive effect is dependent on the distance between the carbonium ion and the alkyl groups. Okay. So Here the inductive effect is less effective than hyperconjugation. By seeing these three structures, we can say, we will generally think that it is more stable, C is more stable than B, which is more stable than A. But that is not the correct answer. It is A which is more stable than B, which is more stable than C, because the inductive effect is possible up to 3 carbon atoms only. Here this is the carbonium ion 1, 2 and 3. On the 4th carbon, the inductive effect is negligible. Inductive effect is negligible from the 4th carbon onwards. So, inductive effect is not considered in this case. Only hyperconjugation is considered. And depending on the number of alpha hydrogen atoms, these alpha carbon atoms are the carbon atoms adjacent to the double bonded carbon in this case. So, these are the alpha carbon atoms, 3 alpha, 1 alpha, 3 alpha hydrogens, 1 alpha hydrogen and no alpha hydrogens. So, the stability order will be A greater than B greater than C. Coming to the next example, this is wrong, this is correct. Coming to the next example, this is nitro group is substituted on the benzene ring. Nitro group is minus R effect. It causes the minus R effect. That means it is electron withdrawing group. Minus M effect, we can say minus M effect causing group. It withdraws the electrons from the benzene ring because it is more electronegative than the benzene ring. So, it takes the electrons which destabilize the carbonium ion. So, this group, this structure has minus M effect and also minus I effect, This group shows minus M effect and also minus I effect, and the same here minus N, and this is a special case, and here also it is minus M effect and minus I effect shown by the nitro group present on the benzene ring. And in this case, the nitro group is present on the meta position. The groups present on the meta position will not show any mesomeric effect. If groups are present on the meta position, those groups will not show any mesomeric effect. So, no mesomeric effect, no M effect, only minus I effect is shown by this nitro group present on the benzene ring. So, two groups are operating in the first one, A, and only one effect is operating on B, and two effects are operating on C. Okay. Now, which is more stabilized? Here, only one effect is operating, so B will be more stable. B will be more stable. Okay. So, B more stable than A or C. Here the same minus M effect and minus I effect both are operating, but here minus M effect is same but minus I effect. In this case, minus I effect is very near. It is very near. The distance will be deciding the effect caused by the nitro group. Here it is very near and it is very far. The minus I effect caused by the nitrogen NO2 group is less when compared to the minus I effect caused by the nitro group present on the ortho position. So, which is more stable? The A is B greater than A greater than C. That is the order of stability of these three groups. Okay, students. So, while considering the inductive effect, if the similarities appear between different structures, we have to consider the distance also. Okay, students. All these examples will be very useful to identify the stability order. Okay students, hope you find this video very useful, and it will be very useful for the NEET and JEE examinations. Okay students,